Okay, so yesterday we did systems of equations and we did the graphing method. We can't use the graphing method for every kind of problem, especially when there's decimals or fractions like a half, a third for the answers, because you really don't know exactly where they are crossing, right? So the and also when the numbers start getting really grossly large, it's going to be hard to fit that on a graph. So we need other methods to get the exact answers. We have two other methods that you guys have been exposed to at some point. One is called elimination and the other is substitution. Okay, every problem might be better suited to do one method or the other. If two equations are in slope-intercept form and the numbers are nice, like the y-intercept is 3 or 2, you might want to graph them. But if the equations are in standard form, like these three are, you're going to want to do a different method because it's tedious to get these equations in slope-intercept form. And you'll see that if you do get them in slope-intercept form, the y-intercept might be like 3.5 or 7.5, and then you're going to have a hard time graphing these. So how do we do elimination? What you want to do, elimination is my favorite. I love elimination. What you're going to notice about elimination is your equations are in standard form. What is standard form? The x is in front, the y is next, and then the constant. Your job is to get a coefficient by multiplying. Sometimes you don't even have to multiply, but you're going to look for coefficients that are the same but opposite signs. For example, this is a perfect case. See how you have negative 3y and 3y here? If you were to add these two equations up, what would happen to your y values? They would cancel. A negative 3y and a positive 3y, if you added them up, you get 0y. So we're going to eliminate one of the variables by adding or sometimes subtracting. In this case, we're going to add. So if we added these two equations, can you tell me what your new equation would be?
6x equals 60.
Equals 60. Very good. Now, how would you figure out what x is?
Divided by 60 less x.
So x is 10, right? So now, how can we figure out what the other variable is?
Plug x into the
Plug
equation.
this in either equation. It doesn't matter which one, you'll get the same answer. Which one do you like better?
Top one. Top one.
Top one?
I like bottom.
Now, why do a lot of people prefer the bottom one? What's the
Because they're
reason?
all positive.
Because of that negative here, I would stay away from that. We tend to make more errors with negative numbers. So let's do the bottom one. Let's do 4 times the x value. I'm just going to write it out for you. You should be writing this stuff down too also. You're going to plug 10 right in here. So what is 4 times 10? It's 40. And then what do you do with 40? Whoops, this is 46. 46. Subtract 40, and you get 6, and then divide by 3, y is 2. You can skip some steps. You can do them in time. So now we got an answer. X is 10, y is 2. So if I were to, we're going to write our answer as an ordered pair. If I were to describe these lines, if I were to have graphed them, can you tell me what they would be doing on a grid? Would they be laying next to each other? Are they intersecting? Are they parallel? Are they the same line?
Intersecting.
They're intersecting. These are intersecting lines. Are they independent or dependent lines?
Independent.
They're independent. They're each doing they have a different slope, different y-intercept. Independent. Now, when you get an answer, when you get the two lines to crash and collide and intersect, we have an answer. It's a consistent system. Okay? This is a consistent, when you get an answer, it's consistent. All right, the next example. Letter B. Check out this one. What do you notice about this one? If we added these two equations, would we eliminate anything?
No.
No. So we've got to be smart and figure out what could we multiply one of these equations by so that way we could add them and get rid of something. Go ahead.
Out of 1 by 2?
Yep, by 2.
Negative 2.
Negative 2.
I like -2 because then we'll end up with a -2 here and then we can add them. Okay, so the top equation, it's going to stay as 2x minus 3y equals 8. But the bottom one, if we distribute all the way throughout the problem, you end up with -2x minus 10y equals a positive 18. The most common mistake on this is people forget to multiply the -9 by the -2. So don't forget the whole thing. Now, when we add, what ends up happening?
The 2's cancel.
You get -13y equals 26, then what?
Divided by -13, you get -2.
Yep, -2, excellent. Now, how do you find the x value? Which one do you want to plug it in?
One.
Bottom one.
Top one.
Top, I think the bottom one we should, because there's no negative here.
Negative.
Yeah, no.
So let's do x plus 5 times -2
What?
equals -9. And you get x minus 10 equals -9. And if you add 10, you get x is 1. So the answer to this one is 1, -2. So let's describe, these are also intersecting lines. Are the lines independent or dependent?
Independent.
Independent. And it's a consistent system. Whoops. Consistent. My eraser just broke. Okay, next. What do we do in this one? Think about it for a second. I can't think of something I can multiply just one equation by, so I'm gonna have to go, I have to do something to both of them. Now you've got some choices. Do you wanna get rid of x, or do you wanna get rid of y? Doesn't matter. Dwayne,
Multiply the top by 2 and the bottom by, well no, multiply the top by 2 and the bottom by -5.
you can do that. You can multiply this top by 2 and the bottom by -5. In that case, he's getting rid of the y's. Now you could have multiplied the top by 9 and the bottom by -6. Anyone think of something else they could have done?
You could have multiplied the bottom by 2 and the top by 3, or -3.
You could have done 3 and -2 and gotten 18 here. Yep. So you have choices, it's up to you. Whichever way you decide to go, it's, as long as you do it mathematically correct, you don't make any math errors, you will get the right answer. So let's go through and let's do what we first said we're gonna do. Let's multiply the top equation by 2, so you get 12x plus 10y equals 44. And then -45x minus 10y equals -55. Okay, these y's cancel out, and what do you get here? -33x is equal to
-11,
-11.
which equals x plus 3.
It equals what?
1/3.
3.
Now, 3, what is 33 times 3?
Oh, my bad.
It's 1/3. Very common mistake. So how, now this is a classic example of why we need these other methods, because it would be very hard to find 1/3 on a graph, to be exact. Okay, so now, what do you do?
Okay, then plug in 1/3 to one of the equations.
Whichever one you want, let's do the bottom one, 9 times a third, what's 9 times a third? It's 3. So this is 3. Subtract 3 from 11, you get 8, and divide by 2. So the answer is 4 1/3, and again, these are intersecting lines. Intersecting, these are independent lines, and the system again is consistent. These are intersecting. These are independent. And the solution is consistent. Okay. There's another method. Yes.
Wouldn't it be 1/3 4?
Yeah.
Oh, thank you. Good call. X comes first. Yep, you are absolutely right. 1/3 first and then Y, and then the 4. Now, what happens if they don't use X and Y? Always alphabetize your letters. So if I used A and B, A would come first, then B. If I used R and S, R, then S. Okay, so always alphabetize your letters. Okay, the next method is called substitution. What you're gonna notice in substitution is that one of the equations usually is solved for X or Y. Think of it as one equation in slope-intercept form and the other one's not. Or they both could be in slope-intercept form. What you're going to do is if one of the equations is solved for Y or X, you're going to put, I would put parentheses around this. So they're saying Y is 2x minus 1. You're going to take 2x minus 1 and you are going to slide it into the other equation. Where you see Y, you're going to replace it for 2x minus 1. So you're going to rewrite the second equation as 4 times x minus 6 times the quantity 2x minus 1. You are putting this quantity in this equation for Y. You're renaming this equation all in terms of x. So you no longer have two variables in this new equation. So what do you think you should do next?
Distribute the negative.
Distribute. So that's why we went over all that distribution stuff in chapter 2. You're going to distribute negative 6. So you get negative 12x, and negative 6 times negative 1 is 6. Next, what are you going to do?
Add like terms.
Add these up, you get negative 8x. Subtract 6 from 10, and I get 4. And when you divide, do you get negative 2?
Negative half.
Good, negative 1/2. Negative 1/2. Be careful, watch. I knew you're gonna trip. Thanks.
You messed your name up. I think that's you at the end of that one. Yeah.
Okay. What do you do to find the Y value now? Is the camera messed up?
I fixed it.
Thank you. You're gonna plug negative 1/2 right here in for Y. This would be the best place. You could put it in here, but you've got Y already as 2 times the quantity of X and then minus 1. So you could do this all, you could do it in your head actually. 2 times negative 1/2 is?
Negative 1.
Negative 1. And what's negative 1 minus 1?
Negative 2.
Negative 2. So again, we have a consistent solution. The lines would be crossing, intersecting at negative 1/2, negative 2. And we have independent lines. Same as the last 3. Now, you're required to know all 3 methods. If I asked you, you might look at this next one and say, I want to do elimination. I'd probably want to do elimination on this. I'd multiply the top equation by negative 4. But we want to make sure that you can perform substitution on a problem like this. So how could you have one quick step? What would you do?
Subtract 2 left.
Good. You're going to rewrite this as x equals negative 2y plus 2. Now, regardless of if that's what you want to do, you have to be able to perform substitution on this problem. So now right away, I put parentheses around that quantity. And I click this and I drag it into the other equation. I think it helps me to draw arrows. The arrows direct me into where I'm going. So then my eye goes, okay, 4 times negative 2y plus 2 minus 5y equals negative 31. Sometimes people, if they don't write, if I don't draw an arrow, sometimes you may, like your eyes might go 4x minus 5y equals 2. So this just helps me keep focused on this line right here so I don't make a mistake. Now, again, you're going to do exactly what you did last time. You're going to distribute. 4 times negative 2y is negative 8y. 4 times 2 is 8. Minus 5y equals negative 31. Combine these two, you get negative 13y. Subtract 8, you get negative 39. And divide by negative 13, and y is 3. Beautiful. Now how do you find the x value?
Plug it into x equals.
And see how you can do this in your head? What's 3 times negative 2? Negative 6. What's negative 6 plus 2? Negative 4. So what is the solution? Negative 4 comma 3. So again, these are intersecting lines. They're independent and it's a consistent solution. Okay, so all we basically looked at so far are the solutions that were independent, consistent, intersecting. What happens algebraically when we look at the other two cases, the no solution or infinite? Well, let's look at these last two right here. Okay, so check out this example. And I'm going to let you pick out which method you think is best suited for this problem. Which one? Substitution? No, I wouldn't do substitution. I would do elimination. What are you going to multiply the bottom equation by?
Negative 2.
Good, negative 2. So let's do that. The top equation, I leave it alone. In the bottom one, I'm going to multiply everything by negative 2. Don't forget negative 2 times negative 1, which is 2. Okay, when I add these up, what happens?
You get 4.
What happens to the x's?
Cancel out.
They're gone. What happens to the y's? They're gone. And you get 0 equals 4. Does 0 equal 4?
No.
No. When something like this happens, this is a case of no solution. If you were to graph these, which case look like no solution?
Parallel.
These are parallel lines. They're never going to cross. These are parallel lines. So without even graphing, as long as I didn't make a math error, these are parallel lines. Are the two lines independent or dependent?
Independent.
They're independent. They're still doing their own thing. They're independent. They're independent of each other. And did we get an answer?
No.
No. So it's inconsistent. Questions? So that's an example. When you see something weird happen like this, 0 doesn't equal 4, these are no solution, parallel, independent, inconsistent. Okay, now what about this one? What method do you want to try out on this one?
Substitution.
Substitution. It wants you to do substitution, so let's do it. Let's put parentheses around 2x minus 5, and we're going to click and drop that in right there. So negative 8y plus 4. Does anyone have a guess what they think is going to happen?
0 equals 2.
Yeah. So let's distribute the 4. The x's, whoops, did I make a mistake? Yes.
I have 8x.
No,
I got that too.
I got it too.
It's
This is
negative
x.
8x.
I made a mistake. I don't know why I wrote y. 8x. My bad.
Oh, I did that too.
You did it too. So the 8x's cancel out, and you end up with negative 20 equals negative 20. Does negative 20 equal negative 20?
Yes.
You could subtract, you could add 20 and get 0 equals 0 to 0 equals 0.
Yeah.
Yes, that's a true statement. So that means there's infinite solutions.
Independent.
These are dependent lines. They're the same thing. It's the same line. They coincide. Is this a consistent, did we get an answer?
Yeah.
This is consistent. We got a lot of answers. Consistent. Okay, do you remember, one last thing, another way to write the answer to this problem? Can anyone say it? Bracket, go ahead, bracket, x comma y, such that, uh-huh, 2x minus 5. There you go. That's how you would write. So in other words, what does infinite solutions mean? It means there's a lot of answers, but it only means the answers that are on this line. You could have written this one also instead of y equals 2x minus 5, but either one. You pick one of these two equations and write it right there. But that's what infinite solutions means. All the points that satisfy this would be a solution. Okay? Yes.
If we write either that or like negative 20 equals negative 20 becomes a solution. Either
Well,
one, would you rather that one be written, the x? The
that,
brackets?
this is, you need to be able to do all of them. You need to be able to write all of them, because on your ACT test, I don't know, they may write that answer. I don't know. I don't have that information. They're not, I'll tell you what, the answer to this question is not negative 20 equals negative 20. This is the work. This is the work for the answer. It's either infinite solutions or you write that. If I'm asking you what is the solution, these are the two answers that you should write. But a lot of people will write negative 20 equals negative 20. That's the work involved in getting that answer. The answer is not negative 20 equals negative 20. It's infinite solutions. Now, if I ask you to describe the lines, you would say that they're dependent lines, they're the same line. If I ask you to describe the solution, it's a consistent solution. So it just depends, Dwayne, on what they ask you. Okay? Does anyone have any questions? Because I'm going to give you your homework, and you've got lots of time right now to work on this stuff. You are going to do, I'm going to write this here. What's that?
What?
Here's your homework. Can everybody write this down? We're going to do this on paper.
No problem.
It's page 146, 147. You're only doing the odds 11 to 17 and 31 to 41. I want you to copy the problem down and skip 37. The answer's like 19, 17, something like that. But I'm going to put the book up and you guys can